And welcome to this session. So because we're such a small group, I think it's going to be very interesting for you because we can really maybe talk about our experiences and really help you debug stuff so that we take some time to go over, everyone, if each of you, if you have an issue or something. Usually when I do big webinars, then you really have to go too fast. But here, I think we can really have the time to work this through. So I'm sharing my screen. So in theory, you should see everything. I'm just going to present myself very quickly. So for those who don't know me, I work at EPFL, so at the Swiss Federal Institute of Technology. I work as a senior applied scientist, and my background is in data science, but in mostly network science, so graphs. And I also, half of my job is also related to the topic of today, which is data art. So we're going to see together, what is the difference between data visualization and data art? How does AI art also fit in this pattern? And hopefully also work on the practical skills, so that we can get you started. I'm not offering or promising that we're going to make a beautiful art piece. It's not the case, but I think I will at the end of this workshop give you the tools you need to really go further and explore it on your own. So let's just start by just recapping what is data visualization. So this is typically what you would see, right? You have bar charts, line charts, and maps and so forth. And if you take a step back and think of what data visualization is, you could say, well, we can extract three goals, right? First, communication. You want to basically have the most efficient way of communicating to your audience with data. So it has to be painless, that the interpretation of data should be very crystal clear, right? If you have a hard time deciphering the visuals, then it's maybe you're not doing a good job as a data visualization designer, right? So the first goal is communication. Now the second part is about exploration. So maybe if you work and after we'll probably do, because we're still a very few number, we can really make a round table and maybe each of you can present herself or himself. But just for exploration, if you work with data, maybe you're a data analyst, data scientist, machine learning engineer, and so forth, you work with data, and sometimes you need to create charts to be able to understand what's in the data set. Maybe it's a very big data set. So you need to also do data visualization to give you a better understanding of the data. So we can say that all in all, it's really about developing one's cognition about the data set, either for communication or for your own exploration. Does it make sense so far? Do you guys agree?
What?
So what I've been saying so far doesn't make sense? Is it close to the experience or? Yes, no?
Sounds good to me.
Okay, it's very interactive, right? We just a very small group. So maybe before we go further, we just introduce ourselves very quickly, just so we know maybe a bit about just your background. So it would definitely help me try to frame the explanations for later. So I don't know, maybe Julia can go first, and then you can name someone else, and you can just make this. We're just 5 or 6 people, so it's going to be very quick.
Okay. Hello, everyone. My name is Julia. I'm from Russia, and my background is management consulting, and I just started a journey into data analytics and also data visualization and programming. So for me, it's very new industry, a new topic, and I think it's very interesting. So I'm really beginner, but I would like to explore this field and to decide if I would like to use it for business purposes, like you show on your slide, or I would like to become an artist.
Can you name someone else so that they present themselves? I mean, or anyone wants to go, it's okay. Right?
Sorry?
And can you name someone else in the room so that you do this kind of ping pong? You name someone else, and then this person has to present.
I don't see. Unfortunately, I don't see the names.
Okay, sorry. So I'll do.
I see only that we now have 4 or 5 participants, but unfortunately I don't see the names.
Okay, okay.
So please ask yourself.
Okay, so I have Brian. Brian, can you?
Oh, yes. Can you hear me?
Yeah.
Yeah, I'm been in background in business intelligence and database management for about 40 years. And one of the things we do as business intelligence is tell stories and, with data, with information. So, I thought this was an interesting topic because the way a lot of visualization that goes on with data, especially as you get into graph databases, and the more visually stimulating you can make them, the easier it is to engage people and tell stories with data.
Great. Yeah, I'll show some of my work is very close to, because I have my background in network. So I'll show you some of my data artworks that are made out of networks, so that will probably fit the graph database part. Very cool. Okay, Caroline or Caroline, I don't know. Sorry if I...
It's Carolyn. So yeah, I'm a product owner for software. So what we do is we generate converters to convert scientific data into a standardized format, the animal format. I don't know if you heard about that. It's quite no, it's not new, but it's for chromatographic methods and for UV vis methods. And what I'm interested in is how to visualize these data and how to connect the data.
Okay, cool. So this session is really about data art. So I'll skim over quickly on data visualization, but you will see the tool that I present that you guys are gonna really work on can do. You see very easily data visualization. That's why I think it's the best tool for the job. I'm overselling it a bit, but you'll see. You let me know at the end of the workshop. We have Planchon. I don't know.
Yeah. It's my last name actually. My first name is Patrick.
Yes.
I'm
French.
I'm French. Actually, I'm located in Geneva, so very close to you, Kirell.
Great.
I guess you're at Lausanne.
I'm in Paris, between Paris and Lausanne. So.
Okay. So I'm located in Geneva. I'm a software engineer with a strong background in business intelligence as well as Brian, I guess. And I'm working now on the iOS app that is intended to provide knowledge graphs on the go on a mobile device. So I'm involved in graphs and visualization as well.
Great. Graph is really my first love. So great. I really love this conference because it's only about, mostly about, AI, but data science and graphs in general. And I think it's a very peculiar conference in the very broad landscape of data science. So I'm quite happy to find other graph aficionados. And then we call it graph, right? When you talk about people in data visualization, when they see a graph, they think of a bar chart. But for us, when we talk about the graph, then we really mean a network, right? So it's a small detail, but great. Okay, Patrick, nice to see you. Maybe you can rename yourself on the tools.
I just don't know how to do that.
Okay.
I tried.
Yeah, okay. I cannot rename you, but it's okay, Patrick. So we have Tonya, I think. And sorry if I'm mispronouncing your name. And then we have someone else. Can you hear us? Okay. And
actually, I don't see Sonia in the
Tonya with a T. Tonya. Oh yeah, you don't. Okay, maybe it was disconnected. I don't know. Okay, so that maybe I don't know, something went wrong. So I think let's continue on that, right? So, okay, so data visualization, we saw everything. Nice. Now, the difference between data visualization and data art. So data art, it's my definition, but I think it's quite accepted with the data artist. It's really about putting the emotions first. So of course it's made out of data because it's data art and not abstract art. But the goal here is not to be necessarily the most precise or the most it's really like different from data visualization, or you want to convey information very efficiently. Here, first we try to put the emotions, but because it's an art piece, of course it has to have a message, otherwise it's not really art, is it? And this message can have different form, but in this example here, you see below we have this explanations. And because it's made out of data, then I think it's really interesting, because the value of the work it's not only in the subjective artist view, right? So I'm an artist, I'm giving you my interpretation of whatever. But here, because it's based on data, there is a more objective truth. Of course, it's still biased, because all data is biased, but still, it's based on the data set. So it has to have a story that is conveyed by the data set itself. And for instance, here, what you see is network visualization of Twitter spread. So that's about the rumor spreading on Twitter. It's a paper that we did a few years back. And then we can really start to analyze the content of the graph but the message here, I'm giving you my interpretation, but it still comes from a data set that you can source. And I cannot say, oh, this is just abstract art and find whatever meaning. It's on Twitter, right? So it has to have a meaning and data related meaning. So I hope this is pretty clear. And all in all, it also helps you, develop the cognition about the data set, but in another manner. Here, it's about if you make a good art piece, maybe people like it, so they reflect. They like the visual, or they like the message that is underneath. I actually run a study on 300 people, so it's a small study, and try to see how impactful like data art was compared to other types of art, and especially to convey scientific or technological meaning. And people, 81% I think thought that this was a good way to talk about complexity, scientific issues, or technological issues, because without the description, you would like it or not, but having this description and understanding that it is about data really changed your perception. I think 53% of people actually changed. So I asked them to grade, basically, give me a rating. Do you like this piece? Why? And now I give you the piece and the description. And now that you read the description, did your perception change about the piece, right? And how? So this is basically what I try to do as a small study. And this, to me, was really, really interesting to understand how we could use data art as a way to convey information and also influence people. So I hope this is, to me, this is the core differences between data art and data visualization. So now there is this great compromise, because if you want to follow the data visualization principles that we can talk about and learn, it's a field of research, right? There's rules. You cannot do anything you want. So if you really strictly follow this, then you have less space for artistic interpretation, because you have to follow the rules. But if it's an art piece, why we should even care about database design, because it's an art piece. So data art is in between, right? So it's really, and this is what makes it interesting, but also makes it difficult, because sometimes it's too artistic, and sometimes it's too data visualization ish, if you see what I mean. So it's always in between the two. So now let's talk about the design process. So most of you here really have some background of knowing data visualization, using it, analytics, software engineering, so you know this. I'm not sure if you're familiar with the design process. It's very similar to even software engineering process, right? It's like all product. You don't have the ID straight away, right? It's something iterative. You go over it, you change it, and sometimes it's crazy, because I can cite many examples, and I'll show you after. Or you make something in 2 days, but you said you know that you want to spend 15 days on it, because you need to reflect and make it beautiful, and then you try different ideas, and then you try to show it to people, and they prefer the thing that you did in 2 days. So it's not linear at all. Sometimes you have the great inspiration, and it's much better than what you do when you try to refine. And this is where the design part of the data visualization design is sometimes conflicting with just your artistic sensibility, right? I would say. So sometimes they collide, and you want to do something more design oriented, but it loses emotions, or the other way around, right? So it's not like I don't have a recipe to really make a good data artwork, but you can ask yourself, okay, what is the concept? What are you going to talk? So a data set for sure, but what do you want to convey as a message with this? So first you start with the concept, then you find the data, or maybe you have the data and then you have to find the concept that's not conflicting with the data, because we, as scientists, we try to also be true to the data. So I'm not going to cherry pick stuff from my data set just to make my point, right? I want to also convey something that is actually in the data set. But of course, you have to select some of the dimensions. You cannot show everything. So you have to make this effort of knowing what dimensions are useful, how you're going to play with the different shapes, and the balance between something very ordered, like a data visualization, or something completely chaotic. So you also have to play with those elements here. Colors, of course. In my case, I try to use the colors as a way to convey information as you would in data visualization. So for networks, for instance, we can color the communities, right? So a community or network is defined as you have more connection with the people in your community than the outside. So if you form communities, then you have the same color. Then it means that, if you have the same color, you belong to the same community. But if you know a bit about data visualization, you know that we cannot display more than 8 colors. Then everyone's brains start to melt, and you cannot really see more than 8 up to 10 different hues, right? Different, like red, green, blue, purple, yellow. And after 10, you really have to make a compromise. So this is why we get away from the data visualization rules and try to put more art and reuse some colors. That's fine, right? It's an art piece. Is it clear so far? Do you have any questions or comments?
No, not for me.
Okay. So I'll give you some links. So this is, and you notice that I'm showing you here things that are actually not data art, they are AI art, but I just want to show you, I do different stuff, so I'll try to show a bit of the range of what I do. I like AI art, so art made with neural networks. It's not really far from data. So it's not a visualization of data, but you need data to train the network. It's a network itself, so it's still a data structure. And you can convey a different type of emotion. So it's more about closer to really art. I would characterize as general art than data visualization. But it's I think it's nice to have different palettes of possibility, right? So I also do some fractal art. This thing one I showed you before here is actually a fractal. And if you remember your fractal, usually it's a math function that is being repeated somehow. And everyone thinks of fractal as in the 90s, right? It's something that you have the Mandelbrot set. Maybe you heard about this. But you can really make crazy shapes with fractal, very organic. And I think it's something that's not very well known. So just showing you this around, the softwares to do this for sure. It's not this workshop, but just to show you the range if you need to express your artistic sensibility with technology. There's tons, without having to paint. There's tons of way of doing that. Tons of ways. So here, does this ring a bell for people who do data visualization a bit? This kind of color scheme. So let me try to open this. Does it ring a bell, right? When you want to create some visuals, you usually use one of these color maps. Yes? Not really?
Yes, makes sense to me. Just a question, Kirell. Are you reading the conversation panel as well, or are you just expecting us to give feedback in audio?
Yes, because it's a very small workshop, so we are a few people, so don't hesitate to chime. I like when in small groups because you can really interact, and I think it's a better experience, because otherwise I'm going to talk for 4 hours and it's going to be boring. Okay. So really don't hesitate to share your experience and talk. So Okay, so going back to the color schemes, this is very standard, right? You have this in all data visualization packages, good ones at least. So this is something you can use, and we can really talk, if you want, after more about the theory behind why those color maps are like this and how to make a good color map. Here I'm just showing you a website that you can use to make your own colors. So this website is very, very useful because it allows you to check when you create colors that they are, smooth to the eye, right? So how do we do that? Usually, if you type any type of color, if you want to make a good color map, you have to make sure that the lightness is going, increasing in one direction and the other, and you use the same. You should not have something that is like makes waves. Otherwise, it's going to be very difficult to interpret the data. And the best example of the worst color map ever created is the one that everyone uses in science from MATLAB, which is called the JET color map that maybe you know. This one is the worst color map ever created by far. And I can show you just why. Can you see this image here on the right?
Yes.
Yeah. So can you see that this cyan, this seems to be have two lines, like even three lines, like one here, one in the cyan and one in the yellow, that is brighter than the rest. Can you see that?
Yes.
Yes.
So this creates an artifact when you try to interpret the data. It's wrong because this is just a color. Why should we have lighter colors at the middle? And this creates tons of issues when you try to interpret the data. So this color map is used everywhere. You can see it here, how worse, like this bright, and here it's too dark, and it doesn't make any sense to use this one. This is why people have been, now that it was used for 20 years, and now people are switched to something that is more perceptually linear, so that you make sure that the lightness is smooth, saturation and you can check here in this website. You can put any colors, and then you can correct lightness, so they change this so that it works. And then you can also check for color blindness and see if people with different color blindness could actually perceive the different colors that you do. And this is very, very handy as a tool, and you can do that with either like sequential color maps, or if you want to do the diverging color maps. So this is just a small parenthesis. I'm giving you tips more from the database analytics side, and we go back to the data art just after. This one as well, like Adobe Color, or you can find any colors that you want. You can check and automatically extract a color map. This could be useful when you want to stylize your visualizations or art piece, right? What I do usually is I try to take a smooth, so to use this tool to create, to make sure that my colors are really relevant and that they're not too bright, and that you don't have like weird spots that that stands out and for no reason. And then of course I do some post-processing, color grading, but I'm using these kinds of tools myself to for the art piece. So this is why they should be quite smooth when you look at them. So for instance, this is a network visualization. So because it's a network conference about the Montreux Jazz Festival. So maybe you know about this music festival. It's one of the most famous one. And what you see here, each node is an artist that participated in this Montreux Jazz Festival. It has been going on for more than 50 years. And they are connected together if they played on stage. So over time, you have this lead singer, guitarist, and they come with their band, but the band can change over time, right? 10 years later, but the lead singer is always there, so that it connects people over time. And then you have this very interesting visualization because you have this very dense connected center, all the stars of the festival, such as B.B. King, Santana, George Duke, all the people that you would expect in jazz and blues. But it's not only about jazz. This festival is, you have hip hop, R&B, metal, punk, rock, tons of different music. Here, when you are on the outskirts, you can be very popular as a group, but it doesn't mean that you actually connect it with other people. So you can be popular, but you're still in your own small little cluster, right? Okay, does it make sense?
Yes.
Yes.
In this case, Kirell, is it a 3D?
No, it's a static 2D image.
But it looks like it's 3D or okay,
Yes.
but it's just 2D. Okay.
It's 2D. Okay, so 3D network layouts are very, very expensive and not very good actually. So it's difficult. Not sure if I can show you. I have one example, but they made me sign 17 pages of contracts, so I cannot show you this. Try to find another 3D layout, network layout. But you'll see with the tool, when we go to the next part, when we really start to practice how everything is going to be 3D by default.
Okay, maybe one question. What was the website you used for that visualization for net, or the one that shows the color and where?
Yeah, I can. So let me. I'm not sure. I can. If I put things in the chat, I think you can. The slides also could be shared. Then the session is recorded, but I'm just going to send this as we go along here, right?
Yeah, this one.
And I can send in the chat. Can you see that?
Yeah, perfect. Thank you.
So the nodes on that graph are bands or
individual people, right? Artists, musicians, right? Any, if you go on stage, you're here.
And the edges are their contacts with other artists
on stage, right? If you are connected only if you played on one particular concert on stage.
Huh.
So it's only live. It's only for this festival. It's only they interacted together during this Montreux Jazz Festival.
I see. Okay. That's really cool.
Yeah, I'll show you. I can show you actually this example maybe. No, this is another. Okay, let me show you another example related to the Montreux Jazz. So this is a static. I'll show you some other type of work, but let me show you what we did. So the Montreux Jazz is a big deal at EPFL at university because they are in charge of digitizing all the concert, and it's 2.7 petabyte of data, right? So it's really, really big, and I can show you in another presentation. But we basically try to create an experience around this, and so that we let people actually browse and interact with the visualization. So let me just show you this one quickly. If you have more, so it started with the thing that you saw, right? But yes. So this is basically to give you an idea of the data set. 11,000 hours of video. So it's huge, right? It's 2.7 petabyte of data because you have different cameras, right? And even in audio, we try to have each instrument. I mean, at the beginning, of course, it was just bad, and in the 50s, 60s, it was not very good. But now it's 8K. It's really try to stay state of the art in terms of for the technology to digitize the concert. And so basically, I tried to create the kind of map here, and hopefully you see it, and it's not. It's a bit smooth. I don't know, because it doesn't seem very smooth on my end, but hopefully it's not too laggy. And you see this kind of map, or you can click on the artist, and they are connected. And all the points that you see are artists that participated in this Montreux Jazz Festival, and you can see that it comes from they come from all over the world. And when you click on an artist, you have this link that is defined as the musical similarity between artists. And then you can wonder, how do you compute this musical similarity? So we go on each song, and with machine learning, we try to extract the rhythm, the notes, the melody, the harmony, all the audio features that we can think of, and we can basically try to extract. Then you start to compare songs together, and you group them so that you can start to now group songs by artists, and then you can basically have a link, a measure of musical similarity between artists. And this is what you see here, this green, all the green arrows. And the width of the link is proportional to the number of songs, like the musical similarity between artists. So this is was quite helpful as a tool for ethnomusicologists, so people who study the origin of music, to see how, like B.B. King influenced the blues world, right? So you see B.B. King as arrows to tons of different artists. And so this is another way of using a network, creating a special kind of network just for this data exploration.
What's the color of the point in this case?
The color is according to the number of connection that you have. So the more connected you are, the darker, right?
Okay.
And then we also tried to, this festival also started to study the evolution of music genres over time. And you see at the beginning of the festival here, so this, you should read that with time, right? So this is time, this is at the beginning, this is now, and the width of the line here is proportional to the number of songs in that particular music genre, right? So you see that the jazz is more or less constant over time, but we have more and more songs, because at the beginning was only one evening, 2 concerts. Now we have 3 stages, 15 days of concerts. So of course you have more songs now than at the beginning. And you can see even here all the bumps when they open the new stage or when they add more artists to the lineup. So you see that how we shifted from the visualization part to something a bit more, it's still the visualization, but a bit more artistic, a bit more difficult to interpret. And then basically, yeah, creating this network that I mentioned, like this. And now this is another version. So the one that I showed you was the original ID that I had. And now we tried to create an experience that was interactive. So we used exactly the same technique. And now we had this kind of in 3D. And we could have now, you see at this, the center here, we have still B.B. King, Santana, George Duke, like all the main artists. And we put this experience into a museum, actually. And so it looks like this. You go, you enter this half hemisphere, right? Like a planetarium, right? You lie down, you look up to the sky, and you have this controller that it's the prototype version that we redid, where you move it around, and depending on where you point, basically you could see and you could select an artist, and now also read, watch the concerts, and then the different concerts, and then on each concert, the different tracks. So this is what it would look like. You have people inside. I cannot really show everything because of the copyright issues, but you have this 3D network, right? And people can play. This is how they move around the sphere. And then at some point, there's no name. The idea is to be completely lost in the festival and really have people play around. And then when you click on an artist, you load all the different concerts. So people have headphones and they can stay. We tried it. It's more than 100 days. So without sleeping, right? The content is huge. 40,000 songs, so you can really spend the days in it and explore the concert.
Do you have a version available for VR?
No, but it's only tons of copyright issues, right? So you cannot display anything unless you're at the PFL or at the Montreux Jazz, because they didn't think this through when they started it. So people didn't really sign any contracts, and not that they're dead, because most of the artists, are old. Then it's a legal nightmare. So it's difficult to actually show stuff. Sorry. So yeah, this is the visualization here. So I hope it was a bit clear, like the path, right, to create this this idea and the story that goes behind it. So I'm here to tell it to you, but usually you also have it in the description, or you can have it as a video that is next to the piece, right? Right?
How do they select the music?
So they move around this spherical controller, right? Can you see me? So I have this. This is my trusty pig that I use, right? So you imagine you move it around, and we know where you are on the scene, and we use it's a phone. We use the accelerometer inside to also find the direction of where you point, like this. So you can move it around.
So that's a dome of projected light, and the thing that you hold.
Yes, 2 projector, 4K projector that are actually sync and stitched, and you see that exactly as a planetarium, right? You look it up, but planetarium is usually it's at the center here. It's hidden, right? But it's stitched, so it's 2 4K projectors. So you have to calibrate them. Just to move this installation around, it costs around $30,000. and the installation itself is around $300,000. So it's quite expensive.
But I'm just the technology behind the selector is interesting that you're holding. How does it know what it's pointing at?
Because so we have the access. Basically, it's calibrated at the beginning. It knows this is at the center of the scene, like this, right? And then from now we know how far you went from the center, and we also know the orientation, so that we know that you're here and that you're pointing to this direction, so that we know which node you want to select.
But there are thousands, presumably tens of thousands or more nodes, so it can select a very small node in the middle of that graph.
So this is why, if you let me go back here, this is why if you have this fisheye effect. Check it out. You play with this, and then you have this this sphere that comes in. Do you see? Right.
Yes.
So this is why we use that, so that you basically zoom in, because as you can see, there are thousands of nodes and they're very small. Yes. And then it really allows you to find one node, and then we try to put it in front of you, and then you just need to click to select it.
I see. So it kind of enlarges it so that you can be more definitive with respect to your selection, because that's a very powerful kind of an interface if it was effective.
Exactly. I mean, it's used in networks and even in 2D, right? But it's more impressive and actually more useful when you have in this kind of setup where you don't want anyone to be in front of a keyboard, right? You want to have something fun to pass around. It was pre-COVID, by the way. People are not with no mask. Yeah. But not that way, but 2 years ago, just before, like 1 year before COVID, actually. And 3 years ago now.
I mean, conceivably, this is something that someone could have in their home.
Yes, for sure, for sure. Actually, I'll show you later, but I made a tutorial on the cables, the platform you're going to use, how to control your visualization from your phone. So it's not exactly the same, but it's not far, right? You use your phone like this, and you move it around, and you see it moving on screen.
Well, so graphs are notoriously difficult to navigate in 2 dimensions. So this is a very interesting way to get more immersive. And if it's effective, it could be something you could theoretically project, maybe even on a ceiling.
Yes. So it's not, I mean, it's effective, but it's not a mouse, right? So it's going to be, but I think it worked quite well, because you move it around and you don't really care where you click, because you don't even know the name. So the idea is to be a little bit lost in the network, so that you explore tons of different stuff. But but then you pass it around, so it's quite fun. You would see kids. So we are actually quite scared about kids, using it as a basketball. But it was fine. And that's why the final version was actually made out of metal, so that it was quite sturdy. But people were passing it around, and it was quite fun to see. Even like, you don't have to be tech savvy to understand. I mean, it's just one button, you move and you see, right? So, and actually another quick, interesting fact, you see that we have everything as rounds, like as circles, half circles, because it's quite difficult. All the videos are square, right? Or rectangular format. But when you are in a dome like this, you can basically watch on all directions, because, I can rotate and still look up. So it was quite difficult there's no right way of looking at the sky, right? So this is why we had different circles with different orientations, so that everyone could see in their own, I can even show you this, actually. It's on YouTube. Show this, a video wherever they were, right? So this is it's not really unlisted, but you can see this is just a dump of or what you would see in the dome, right? Can you see that? Mm-hmm. Sorry for the poor quality, but so yeah, this is it's a 4 squared image, but then you have this, and then the music would be playing right on hover, basically. Then you can load stuff. I don't know, they chose the craziest example of free jazz, which I hate, by the way. But you see what I meant by the videos are randomly, not rotated, so that wherever you are, you can still see in the right orientation. You don't have to move the neck around too much, right? And then when you click, this is a different concert. And then when you click, you would open this as well, right? So you could see a ton of different small. So we tried this, how we put just a rectangular, and you see everything is moving, but it was actually quite fun. And then they would go back, and you can choose something else, right? So I don't know.
It really looks like a gravitational lens.
Yeah, it's exactly right. It's so this is a BB King concert, right? So you can play around. So yeah, I think you have an idea of the experience like this, and you have the name also. So this idea, being in an hemisphere, like, it was actually quite difficult because we have to figure out. Now that you see it, it seems simple, but it was not clear. If you have a rectangular video, you have to crop them and everything, and it's, as I mentioned, it's 2.7 petabyte of data, right? So it's not that easy. Any more questions?
Is there a link to that video, or
it's unlisted? I'm not sure. I can show you the link, but I don't know. I can show you the link. It's okay. As long as you don't advertise it too much. But the music, I have to warn you, they made a very weird selection. I think it's on purpose. The beginning is some free jazz. It's horrible to hear, just to warn you. I don't know. I don't like this free jazz. I think no one likes this. But then it's BB King at the end. So
or maybe for people not to spend too much time within the dome.
No. I think they chose it on purpose here, so that for this particular excerpt, you don't steal it. I don't know why. It's crazy. This artist, I don't know. But yeah. So let me go back. Any more questions?
This demonstration is available at Montreux Jazz. I never saw that. I've been there quite.
Yeah. So there was for the 50th anniversary at EPFL, and now with COVID, they took it down, and they're supposed to be back up whenever it goes back. But it's actually in China now, so it's not the same dome, but there's the same installation in I don't even know where. So I wanted to go, but you had to do 15 days of quarantine just on entering the country. So I said no. But yeah, it's touring.
Okay, Kirell, just a question. Have you ever heard about the Team Lab in Japan?
Yes, of course.
Okay. Have you been there?
No.
Okay. I think you should investigate and maybe be in contact with them, because there is some overlap or some connection from what you do and what they do as well.
Yes. Yeah. So starting in the next month, I will be working at this lab at EPFL that construct these installations, and they are in connections. And so we have tons of new exhibition being planned about astrophysics, always science, art and science related, but they are very cool installation. We have some 360-degree screen, 12 meters in diameter. So it's like how many? I don't know, 18, but I don't know, 8 projectors, stitched together, and it's like a 360 screen. But now we have to design and produce content, and it's actually very difficult because it's very, very high resolution. Imagine you have 8 4K screen stitched next to each other, and then you have to produce a live visual that is at 60 frames per second. It's quite challenging, but I'm quite eager to make some connections. And they know that, and they worked a bit with Team Lab, so probably also work with them in a few months.
Okay.
So yeah, I just wanted to, I don't know, I'm not here just to show my work. Then we're gonna start the practice part, but I can show you other data-driven thing just for inspiration. This is a fractal. I'm just slow. And animation here. So the fractal itself is about the increase of sea level from the glaciers are melting, and as they melt, you see that this central shape grows. And the camera itself is also driven by the tide in Bordeaux, so it's a city in France. And so I tried to have the data baked into the animation itself, so that the visual is abstract, but if you look at the animation and you know the story, then it starts to make sense. And then at some point it's receding, because hopefully we do some stuff to make it stop, and then it goes back to normal in the future, hopefully. So this was the idea around this, and just another way of expressing and still being in data art, because you are still using data to drive the animation. So it doesn't have to be necessarily an artistic data visualization to be data art, right? So it's a small animation. It took me 120 hours to render back in the day, but now I actually run it in 4K, and it took me a few days, but I have a much better computer. So it's quite slow to render fractals, especially when they are not GPU driven. So you have to a lot of CPU run. Any questions on this?
No.
Okay. And lastly, I'll show you this one. So this is an AI-driven piece. So it's close to data art, but it's not exactly data art. And as you can see, this is in Paris, next to in front of the library, the big library. So it's quite big. So once again, doing data art and looking at it on Instagram is completely different as an experience than having something very big, as I show, or the dome, and it really changes the dimension. It doesn't really change the artistic complexity or message, but still having this kind of immersive environment really helps push the from just a nice visual to something more artistic, I would say. So if you have any connections or new companies or big screens of the ability to project, I would definitely encourage you to do so that it makes it more vivid and more immersive. So,
but in this case, where are data?
So here it's AI art, right? This is another.
Oh, okay.
So it's you can say the data is when you train the network and everything, but the visuals are not. It's not data driven. I mean, it is data driven, right? Because you still use you make it basically you have this network that is trained, and then you make some queries or you make it explore different paths. So you send it data, but it's not a data visualization, right?
Okay, but still you signed it.
You saw? Sorry, what?
You signed it. There is your name on the.
Of course.
Yeah. Okay.
Because it's not. It's like saying I'm using Photoshop, so I should put Photoshop, right? If you train the network and you put some queries and you basically even select. So if you create the video, then you have your artistic input, your sensibility, and your skill, right? Comes into it.
Obviously. Mm-hmm.
And in this situation, what data did you train AI with? What were those images or images of what?
It's ImageNet, so it's the very common and famous dataset. I can show it to you. So it's and it's a very standard state-of-the-art dataset, and they have 14 million images, basically, with different categories like cats, dogs, pigs, cars, objects usually. Yep. And then you can train so that you can use another network of with images of landscapes. So in this particular case, it's a combination of different videos. This is one landscape, but before it's abstract shape, or more about the. I like the abstract art, so it's very funny. I can also show you this. These are not flowers, and you see that they really look like flowers, I think, but these are the different ingredients that were used to create the visuals. And you have the custom-made music also that works. So it really looks like flowers, but check the ingredient: traffic light, cat, butterflies. So it's an insect, comic book, strawberry, guinea pig, and more. So I think I like it because it gives us information about how we perceive things, and that actually for a network it doesn't make. It's no problem to mix different ingredients, and we still, so that it's like decomposing a shape, an object into very atomic different shapes that you recombine, and you can recreate something that looks familiar. So to me, this was interesting to play with. Yeah, it's different stuff. So I mean, I'm not gonna show over all my stuff, but does it answer your question?
Yes, thank you.
Okay. So now it's almost 8, so it's good that we start working with the technical part. So I'm gonna talk, but you're gonna practice. We're gonna do this together. So this is, you work in data, so it's fine. Just to make sure that we are on the same page. This metadata and items. So you have data as a type, and you have datum. I see data with an S, but data is already plural, right? So datum from Latin as a type, and usually this is what you get from when you work with data art. You have either a database or mostly tabular format. You can use a graph database, so it's not exactly like this, but you have this would be the properties of your nodes, and then you have another table or a way to link different items together. So an item, it would be here in our case a row, right? And our goal here is to transform this into visual objects that hopefully are beautiful and make sense. So I just for to be nice with the definition. An item would be this. This is another way of, if I show this, does it ring a bell for everyone, this JSON representation? So I can skip over quickly, or is it new for you and I spent more time?
I guess that's okay for some of us, but maybe not all of us. It's
For me,
okay for me.
it's new. I would appreciate a bit of explanation, please.
Okay. So.
But very brief.
No, but you see that, right? This is a standard CSV for representation, right? Excel spreadsheet, right?
Yeah.
Now you can say that each item here can be also, that this line belongs to the same item or object, right? It's the same, these are different properties or attributes of the same person or item. Now, usually when you work with data, especially on the web, you don't use this columnar table representation. You group objects by item. So you use this, what we call this JSON representation, which stands for JavaScript Object Notation. And you know that when we work on the web, and this is what we're going to do, the language of choice is JavaScript. So there's the language that we all have on our phones, even on our watch, everywhere. The most popular programming language, not the best one, but unfortunately, but the most popular. And we group items together, right? So this is the representation. So it's quite easy to read, but you have to enclose each object with these curly braces, and then you have to put your key in quotes or double quotes, like, okay, this is my ID, right? And this is basically how you send data, and we're gonna work with this, send and receive data. This is also how you import them into the tool that we're gonna use. So all the tools that you have can convert, export their data to JSON format. And right? And even a graph is also, usually you have a list of nodes like this, and also a list of edges, which are just giving you one is connected to two, two to three with optional attributes. Okay.
Yeah. Okay.
Great. So as I mentioned, now our goal here is to transform these objects into elementary visual elements, right? What we call technically marks, so visual marks, which could be, a square, a rectangle, a triangle. And then we map some of the other attributes, so those guys here, to visual properties that we call channels. So if you look for the data visualization language, they usually use marks and channels. So channels would be a visual attribute. So you say, I'm mapping the shirt size now to the size of my square. Makes sense, right? So you have to, there's a whole theory about this, but all of what you see here are visual attributes. So position, scale, orientation are really the fundamental blocks in 3D, right? Color, of course, we're going to use colors. If you have, here, you already have colors, but sometimes you could say, I'm mapping the shirt size to a color. It's fine if you have like 4 or 5 shirt sizes, then it could also be represented as colors. So this, all your sensibility and technical knowledge to know which attribute to use. There's no general rules, but with practice it comes. Okay, so marks and channels. And now you can ask me, what about unstructured data? Because it's fine, but not everything is a table or nicely formatted data. For instance, what happens when you have text, or if I give you audio, as I mentioned before, we basically have to transform into structured data. So we use some what we call AI now, but before it was just machine learning or statistics, but try to find, to extract some features. For instance, you can automatically find the subjects in the sentence, the objects, describe them. If you work with the structured data knowledge graph, or try to describe ontologies, how things relate to one another. What do they mean in different, across languages? For instance, I call it a dog, but in French it would be a chien, but it represents in your mind is the same object, irrelevant of the language. So this would be an ontology, for instance. And so there's no, once again, ground rule. You have to, it really depends on your data set. That's where all the jobs are and all the difficulty is, right? How do you create the models to map your data, right? So we extract meaningful features, then we can start to visualize. So, okay, you can ask me, okay, I'm really, now, okay, I like this. I want to be data artist, but I don't have any data set. So I'll just give you 2 cool reference. So if you want to browse and find data set that would be of interest, I actually give you 3. One would be this GitHub repository. As you can see, it's quite popular. And people are trying to organize data set according to broad content, right? So finance, geospatial information, healthcare, and so for museums, right? And so I'm gonna keep this here. And also another very cool source of information would be the Kaggle dataset that you are, okay, who here knows this Kaggle stuff? Does it ring a bell, or is it new? Okay, so it's new. So this has been bought by Google. This was like it's still the home of all the data science competitions. People try to exercise their skills, and basically you have challenges. Companies pay also. People say, oh, we have this problem, do your best, and if you win, you gain some money or anything. And so people really work hard to try to, as you can see, so teams work, right? This is not the one individual. Usually there are teams. People sometimes do this for a living. They only apply to challenges, try to win and find all the tricks to win the competition. But the very interesting part is also this data set. So as you saw, there's like 100,000 different data sets here. And then you can really start, for instance, the COVID data set was quite nice. You had like all the papers, so it's pretty big. Some data sets are really small, some are really, really big. So this could be very also inspiring to you if you have some, I don't know, you want to do music. So, and then try to find, features, MusicNet. So this is a very old data set. We make our own actually data set. If you are interested in music, let me know. I have tons of experience in this. And right, and then I like this data set, the top 50 Spotify songs. And some people can give you a CSV file, then you can download. So it's a very, very small data set in this case. And then we try to transform this into visual elements, right? Okay, but probably you also have data in your own company. So of course the goal would be to apply this to your own data set, which would make more sense. But if you want to exercise and you cannot, don't have the rights or anything, you can use those two sources. And just as an idea, you can also create your own data set. So for instance, and this is what we're going to use here today. I'm not sure if you know this website. You guys know this, Last.fm? Does it ring a bell?
Yes.
No.
Okay, so we have one yes. So Last.fm is just it's a website that tracks your listening habits. So you can create an account and basically connect it to your Spotify / YouTube / Apple, Deezer, whatever platform you use, and it would track how many songs you listen to, which songs, and so it'll give you a bit of statistics of your listening habits. I think it's a pretty nice website. It's free. You can pay for more detailed analytics, but you can export it. So one could be this, right? This is something that you can create yourself. You could also export your WhatsApp messages and try to analyze the connections and how you reply. So there's sort of data that we create every day that is more or less hidden, but if you think it through, you can really extract them quite easily. There's an app that I like, it's called Arc, that tracks every move you make with your phone, but it's stored, it's not on the server, it's on local to your phone. Then you can export it and use this as a file to see, let's say you go another country and you visit a city and you would like at the end of your trip to see where you went and how, you could use that as a data set also to work with. Okay, so this is what it would look like, and this website is pretty cool. I'm gonna give it to you because it's not necessarily well known. It's just a way to export all the Last.fm data that you have when you are logged in, right? So you can say, so if you start now, of course you need to wait a few months to have a sufficiently big database, but over time you have tons of different artists and tracks and everything you can listen to. Okay. Questions so far? All good? So I'll share with you this data set. I can actually put it here in the chat so that we can try to work with it when I'm after. Okay, so this is what we're going to do now. We're going to work with this tool, cables. and I'm sure you never heard of it before, because it's not new. It's been on for like a few years, but they really start to make it so awesome that people are start to join in, but it's still not as known as D3, for instance, and other libraries that you may know for data visualization. So what is this Cables GM? This is a platform. It's not just one tool or live framework or library. It's really a platform. So let me go on Cables, and I will invite you to actually create an account, because this is where we're going to play today. So if you go to cables.gl, on the right, you will have this register and login, and you can now go and register, put your email, wait for the confirmation email, check your spam folder, and go here. So I'll give maybe you guys two minutes so that we can do this, and you let me know when you're here. So when you create an account, then you will reach this page basically. Okay, so go on Cables GL, go on the top right, register, and then you can come. So what is this tool while you do this? This is a node-based visual tool. So you don't have to code anything. You can code if you want to. So this is the page, right? You would see register on the right. And it's basically, it's a node-based visual framework on the web to create motion graphics, data visualization, data art, AI art, anything you can think of. And as I mentioned, it's a no-code tool. So you can use this without having experience in programming. But if you know how to, you can create your own blocks. It's like Lego blocks that you plug, basically. And if you know how to, then you can start to program with this and extend the library. It's free, very important. It's a free tool. All the work that you create, the projects which are called patches, are free and your own. So you can download the data, export it to a website, and so forth. So it's really underrated and awesome library. I've been involved with this community for the last 2 years, and I do now all my work and all my workshops I do with Cables. I think it's the best tool for the job, especially in this kind of setup of while we do workshops and everything. So are you guys here? Did you create an account?
Under register.
Yeah. Then if you put your email, you're gonna check them and see if you received it to basically enter the thing. And you're quite lucky because like 2 days ago today was a very big new release, so they had tons of new stuff, and it was quite impressive. They also have a YouTube channel, or they show all the kind of tutorials, and I also have my own YouTube channel where I show tutorials on how to use this tool, so you can really find a ton of information. But I just wait till you guys are here, and maybe we can do a quick break if you want once you are registered, so that we I don't know, maybe we take 5 minutes.
Yes, would be good. 5 minutes would be good.
5-6 minutes, and so just so that you hear, and then we can restart to work on the patch. Okay.
And I have one more question about CVS file, because I'm really new to this. Do I need to convert it to something or just download it?
No, download it for now, and I'll show you. Just download it, and then I'll show you everything. Don't worry.
Okay, thank you.
Okay, so it's 11. Let's do 5-6 minutes, and we come back, so you guys have time to create an account and be here. Okay. All right. See you in 5 minutes. welcome back. I hope that you had the time to grab a drink. Please let me know when you're back so we can move forward.
I am back.
Great. Yeah, it's a bit late, so I'm not sure if people come from Europe, it's starting to get late. And maybe you need to eat or anything. If you're from the US, then it's morning or afternoon, right?
In Russia, it's 10 p.m.
You know, I asked the organizer, but they really wanted to push the hours. I mean, to put it later. I was like, okay, but I probably would have been easier if a bit earlier, especially for you. But we have to make the best of the situation. Are the others here? You guys back? Not yet. Let's wait 1 or 2 more minutes. But back and ready. Okay. Terry, nice. Okay, so if you are back, can you put in the chat if you cannot talk also as well? Okay. 2 more people. Patrick, are you there? Brian? So while they come, so this is the interface, right? You come here and so what can we do first? First, important, the top bar, we have this learn tab, right? Or you have all the examples, documentation, some videos, and this community. It could be also very handy. So most people are connected on Discord, and this is where we exchange, and when you get help, it's very friendly community. Every Wednesday, there is a meetup at 7:30 CET at night, and people can come with their questions. We talk about the latest visuals. So just to show you an example, if you go and explore, browse all the patches, then you have like the latest project that have been made with this framework, and you have really cool examples, completely unrelated. Sometimes it's about showing a new example, sometimes about motion graphics, such as this one. And then you notice that this runs in your browser, right? So this is live visual. You can have this work on your phone as well. And if you give this URL to anyone, then you will basically have a link to your interactive visuals or your data visualization or your data art piece. So just a simple example, something that I did recently was just about creating this AI image, but I wanted to have it a bit like immersive, right? So I just mapped this into a sphere, and hopefully you can see how it works. So some people say they have no mic anymore, so can I do anything for this? Yeah, I don't know. I'm not sure about this platform. I'm gonna open all your mics, maybe. I don't know. Can I open your Patrick? Wait. Stop stream. I don't know what this is. Are you streaming? I don't know. Okay, mute. Okay, I'm unmuting you. Maybe I don't know. So yeah, this is just an example. As you can see, this is just also a link that you can send to anyone. You can put it on social media and it works. So it also acts as a platform to host your content. Of course, if you want to host it yourself, you can do that. But it's what I like about this tool is that you don't have any hassle. You make your visual. You can have it private, but when you make it public and it goes here, and you can share any URL. You can also share a private URL. For people, for clients, for internal to the company, and just let me show you some of the coolest patches, right? So, for instance, this was made 4 years ago, but it's I'm not sure if you see when I put full screen. Right, I'm not sure if it's smooth to you on your end, but you know, this would be quite difficult to code if you don't really know how to do this. But you will see with cables, this is just a matter of a few blocks actually. So it's pretty neat. So if everyone is back, so this is the main page, and we're gonna start with this create. So on the top, create empty project, right? And if you do that, this is where we'll be. We'll be in this empty page here. So can you see that? This empty page? I mean, do we have any mics issue? Because if no one can talk, it's going to be tedious.
I'm there.
Okay. So I can, yeah.
Test.
I try to open the mic for everyone. Yeah, okay, nice. So you're here, right? And I have my mic off, but I get audio. Cool. Yeah. So you can mute yourself after. Try to unmute everyone just to make sure that it didn't have any bug or anything. But okay. So we're here, and it could look a bit daunting, right? So you go here and say, okay, what do I do? What happens here? Especially if you don't know how to program, right? So what we could do now is to. I'm still here on the mic. Who is? I'm trying to mute people, so please mute yourself and unmute yourself only when you want to talk. Yes, thanks. So we're here, right? The shortcut that we're going to use all the time is going to be the tab key. So the tab key is the. Can you hear? I hear some echo somewhere. So I'm going to mute everyone. Okay. Oh, just open your mic if you can. So when you're here, the tab key will open this window. So the tab key is next to the Q, or on the top left of on the left of your keyboard, right? The left hand. You have this tab key. You can also press Escape, which will open this menu as well. So how does it work? Basically, this is where we're gonna put the Lego blocks that we need, that we call op for operators. Here on the right, this is where we see the live visuals, and here below we have basically the options of each block. Okay, when you go here, you also have some more options like patch setting, and we can call this data. I don't know. Data art initiation, whatever you want, initiation, and you press save. And don't forget to save. This is something that is a bit weird, but if something happens and you need to reload the page and then you didn't save, you're going to lose stuff. So to save, Control S, Command S, as you would do on any software, right, to save the patch. Of course, for now, it's empty, so nothing can happen. So the first thing we're going to do is we're going to put the main block that basically sets the loop so that we can draw things on the screen. And because it's a loop and it's the main object, it's called main loop. So you see I'm typing with my keyboard main loop, and it's autocomplete stuff. And then I can add by clicking, or I just use the keyboard enter and putting this node here. So now notice that with my my mouse, I can scroll and it's infinite, right? The canvas. When I click on this, I have more options that appears on the right. So is it okay for trying to open the mics again, Patrick? Can you talk? If you, yeah, I'm not sure if it's not working very well. So can anyone talk? Because I don't hear any feedback. So
sorry,
okay.
where I should type main loop?
So you press tab and then you just type
Yep.
main loop, and notice
Okay.
so, and then you can add it. And if you go back here, these are
Okay.
all the possible operators. These are the broad categories that we have, and there's about 2,000 blocks. So of course, it's going to take some time to know everything, but there's a logic behind it. So it's not that long, actually. It's really by big categories, and we can cover this. So most of them are in one big category, and we go through this. So we have the main loop, and when you click on it, so you notice two things. We have inputs here, green inputs, and outputs. The inputs that you see here are the same as what you see here in the tab, in the menu on the right.
Okay.
Right? It's exactly the same. And the idea of cables is to connect stuff so that you, instead of configuring everything here, you basically connect blocks to blocks, and you basically set the input of the next block by taking the output of this one, for instance. So the first thing we're going to do, don't worry if you have tons of different options. The green inputs means that they are either numbers or true or false value checkboxes. And we have the special kind of yellow output. And this yellow color means that this is basically the way to trigger operations, to say, this is what happened next. So this loop here is being triggered, it's written here, trigger every other ops once every frame to create smooth animation. This is the main renderer. On your computer, the minimum frame rate on the web, it's 60 frames per second. So this guy here is going to execute stuff 60 times per second in the best case scenario. If you have a higher graphics card and screen, you can go 120 hertz, 240 times per second. So 60 times per second leaves us with 16 milliseconds to do everything we want on the screen. If we take more time, then it's going to start to be to reduce the frame rate, and at some point, if it's below 30 FPS, is really going to look sluggish and laggy and bad. So the goal here is to always strive to have interactive frame rates, so the closest to 60 FPS that we can. Right? It's a bit theoretical, I know, but I'll show you an example. So I have this main loop here. And the first thing we're going to try is to change the color of the background because it's black by default, right? So how do you do this? Well, you put another node, right? Because it's about putting Lego blocks. And the node to change the color is called clear color. And you say, well, why is it called clear color and not change background? Because clear color is really the name that is used on the underlying graphics API that we use, which is WebGL, which is also inspired by OpenGL, which has been created like more than 20 years ago. And this is the line of code you use to change the color. So it's called clear color for that particular reason, right? So you put the clear color here on the patch, and notice that I can press my left mouse and put it everywhere. But the idea, yes?
Data art, do you want to do it, the demo?
No, I think it's someone else. So when you have this clear color, notice that here you have some options, and I can move with my mouse the different sliders, or I can click on the color and change it. But I promise that this node was about changing the background, and nothing happens. So why is that? Because the way it works is you need to basically activate, you need to connect this clear color to the main. This is why you need this trigger to say, hey, every frame, for now I do nothing, but now every frame I'm gonna first now go and clear the color. So now that it's connected, now it's very reactive because it changes as fast as we can. So you see, you need this yellow trigger to say, and you can even press, so give you a bit of shortcut here. If you press the F key on your keyboard, you would see this kind of flow. It's called F for flow mode. And then you see that, okay, there is some movement. It goes from here, and then it connects to the clear color and then runs this function or this operation, this block, as fast as it can, right? So 69 per second. Is it okay for everyone? I cannot hear Anyone? I'm not sure about this. I'm gonna ask the.
I've connected the things, but I can't change the color.
Okay, when you go here, you're connected
Yeah.
like this. You have this here, right? This.
No, I don't. Let me check.
Click on the node here. Select this node.
Oh, yes. Now I see.
Right, and this is alpha for opacity, but you can move the slider like this, or you can click on the color box and play around. Okay. So next thing. So notice that when we created our first cable. So how can now you create a cable? How can you remove it? So when you go over a cable, you have this node here, and if you right click on it, it disconnects the cable. So when you disconnect it, then it goes back to the black screen, right? That you reconnect it, you drag the cable, and you can do this, and it reconnects. Okay, it's very simple. We start small, right? Now, imagine that you were to create a moving background. How would you go about changing the color of the background automatically? Of course. What would you use? What are different ideas you can explore to have this background change automatically? You guys need to talk, huh? It's not going to be a rhetorical question. It's a workshop, so if you can talk or put in the chat. But so I'm here, right? I can play with the different sliders. How can I do this automatically? What can you think of a mean of interaction, right? Are you talking, or are you just thinking? Because this is difficult without feedback. So trying to talk, but it doesn't work. So maybe the staff here can help with this. If you guys are trying to talk. Terry, for instance, can you hear us? So the question.
I can advise Patrick, if I am right, to use the URL I sent him to re-log in the session so that his mic is fixed.
Okay. So yeah, if you have an issue with your mic, maybe try to relog, because it would be better. So the question is, how can I make the color change? Right. So now I'm using my mouse, but how can I make this change automatically in some way? Okay. No answer. So should I reveal the big secret? Well, so one thing we can think of is to use time, right? A timer, something that counts. It's just a number of seconds, and this counts, so it changes over time, right? So let me try this. Let me try to put a timer, and it tells you, right, when you put it and you click, a timer that can be start, pause, and reset by triggering. And you notice when I click on it, I have the number of seconds that have been elapsed since we put this. But if I reset, and it goes back to 0, it's always counting, right? It's time. So don't forget to Control S your, and yeah, mute your mic if you don't talk. You have this timer here that is always counting. And once again, this seems to work, irrelevant of the main loop. It's another block that counts and do its own thing, right? So now that I have this timer, this counts. But you notice that when you play with colors, especially on the web, on the web in general, you try to normalize them. So the red value can be from 0 to 1, right? For here, it's 0 red, and then I put 100% red. So 255 values, because it's an 8-bit color, right? So red is between 0 and 1. But this timer here is counting. It's still 50. It's counting the number of seconds. So if I put my timer here, it's going to overshoot the maximum because this value can only be between 0 and 1, right? So can you think of any idea how to make this timer, or to basically map or bound the value between 0 and 1?
You have to modulo, or?
Yes, can you explain what the modulo is?
Okay, I didn't get the start of your question, but I guess because the timer is going until 100.
No, it goes forever.
Oh, it goes forever. So maybe just dividing taking the modulo of the timer by.
Can you explain what the modulo is for the?
Oh, it's the rest of the division. So you divide the timer by 256, and then you take the rest, and the rest is never greater than 256.
For instance, right? So modulo is just a reminder of the division. So let's say I have 10, and I divide by 2. So 5 times 2 is 10. The rest of the division is 0 because it's exactly a multiple of 10, right? But now if I say 9 by 2, then it's not going to be 5. It's going to be 4 plus something, right? So because 2 times 4 is 8. It's going to be 1. The rest of the division is 1. So my modulo will count. So basically, if you put this, this is one way, but because you said it, we have to use it now. But I'll show another technique. But so basically, if we put this timer here and we notice that this modulo is just a math operation and it needs 2 numbers, right? The reminder of the division of one number by another. This is how far we're going to go. So here we're going to divide. The number can never go above 1, right? And we connect now. I'm going to take the input and I'm going to put it here. So I'm connecting the output of my timer that is always counting. Notice when I click here, this is an output, right? So it's always here. And I'm connecting it to my module, my block. And if I put 1, I'm basically taking only the remainder of the division. So it's always counting between 0 and 1. And you see what it does when it reaches 0.99999 up, it goes back to 0, right? And it counts like this. It creates this kind of sawtooth pattern, actually, right? So just to show that, I'm taking this output here and putting in the red value. And now you see how we transform this curve here, this animation that we created from the timer, and we map this to the color. Now, if it's too fast, you can also go on the timer here and slow the speed, right? I can even go backwards. Now it's counting slowly, but everything is still connected as a chain of operation. So this modulo still counts, just a bit slower. And when it's going to reach 1, it's going to go back to 0. And I'm using that to drive the input. So now you notice that I cannot play with the sliders anymore for the red value because it is connected by this cable. So it's either I play with my mouse here or I have it connected by a cable, hence the name cables. Does it make sense?
Yeah, I'm not sure it's working on my side, Kirell, because I think the clear color is using a float value from 0 to 1, and not. Yes. That's the case?
Yes.
Oh, okay. So what value? What is the limit?
Modulo 1. Because
modulo 1. Okay, makes sense then. Okay.
Yeah, it's all the colors are always normalized.
Okay, I thought it was 256. Okay.
So why is it for the other? Why is it 256? Because usually colors on the screen are 8-bit, so they can go only. You can only have 256 different value for red, 256 different value for green, and 256 value for blue. And this is how you compose them, and you get 16 million colors. Of course, the eye can see much more than this. This is what the colors on the screen are always less impressive than real life, right? But usually, yeah, it's here. All the values are normalized between 0 and 1. For the others, yeah, I think it should work. But does it make sense, like the explanations? So another way to play with using still to change. So now we drove the red value. Fine. Let's work with the green one. So notice that I can use the same output and I can connect it to different outputs. It doesn't, it doesn't have to be only one cable. I can connect as many cables as I want. If I drag it onto the node, I can even show the available remaining inputs. So now I'm moving 3 colors at once, and they're all going to be gray, right? If they all change at the same time, it's only being grayscale, gray values. Now, if I want to disconnect the cable, as I mentioned, you just right-click on cable and you disconnect it. Okay, does it make sense? So another way simply to change the color would be to put this timer into a sine wave. I'm not sure it's very far for everyone, the sine wave, but remember the sine wave is the wave that goes up and down between 1 and -1. It basically tells you how many rotations you do around the circle. It's not exactly true, but you get my point. It's basically you go in a loop around the circle. So you can take any angle as input, 1 million, 10 million, whatever input is always going to be around the circle, and the value is always going to be between -1 and 1. So if we do this, let's try this. It's going to be sine or cosine, it's the same basically. Now I'm going to connect this here and check the output now. So you see it start at, and let's put the timer a bit faster so you disconnect this guy here. You see, check the bottom of my screen. You see that you have a curve that is going up and down, right? So it's just a sine wave. Now, the sine wave goes by default, between -1 and 1. But we know that our numbers need to be between 0 and 1. So not -1, because it doesn't make sense to have a minus value for a color. Remember that the color, when you say we put 1, 0, and 1, it actually converts to the amount of electricity, power that you put into the LED of your screen, right? So it has to be a value between stuff, a positive value. It's current or no current, right? And it cannot be minus. It doesn't make any sense. So how would you go about converting this thing between -1 and 1 into something that is between 0 and 1?
By taking the absolute value.
Okay, so this is one solution. So the absolute value means that everything that goes below 0 is basically put upwards. So let me show you. Absolute value. I'm connected here. And now, just by putting my mouse, check the curve now. It seems that it bounces, right? When it starts to reach 0, instead of going to -1, we basically take the value and we put them positive again. So we multiply actually by -1.
So it's not a sign anymore. So
no, it's not a sign anymore, right? Because we put this into the absolute value, and now we can connect this to the green value. And notice that here, we started by creating another curve. This curve here is different from the one that we created by the modulo, right? The modulo was, more like a sawtooth wave. Let me put this a bit slower so we don't get crazy. But here we create another type of animation, right? A very smoother one, but still, when it reaches 0, it bounces.
How do you do to show the wave?
You just put your mouse over the number. Here, but there's another way. You can, with your new operator that was just released 2 days ago, you can use also one which is called viz. Sorry. Number or viz graph. So if you put this here, instead of showing it here, you can just connect this guy here or here, right? And then you can see it here. So it's the little previewer, and you can use that, for instance, now. The modulo next to it, right? So we see the difference between the curve, and you see what happens when they reach 1. One goes straight to 0, the other is more or less continues smoothly, and then goes back slow, right? So, and you notice that we start to have cables a bit everywhere. That's the whole point, right? So we try to organize stuff around. Okay, makes sense for the rest of the group. Julia, maybe in the chat, or Terry, Cyber, Burker, Brian. Okay. So I have one yes, it's clear, fine. So now the last, so we have two colors. Now the last color, we could use the same technique, and I want to show you from the sine wave itself. So as I mentioned, it goes between -1 and 1.
So
now
adding 1 and
exactly
by 2, yeah.
You can do this as well, right? And it's gonna create another type of curve. If I add 1, so it's gonna be between 0 and 2, right? I'm -1 and 1. I add 1, I shift everything to the right. So how do I add 1? Well, sum what goes here. So between -1 and 1, I add 1. By default, it's 1, so it goes here. So now the value that I get is between 0 and 2. Now if I divide this guy by 2, by default it's by 2 again, then I get another number here. We can plot this number here. And this number here is going to be between 0 and 1. But now the curve is going to be very smooth, actually. Something is wrong here. It's just slow. So now the curve itself is going to be, let me put my timer back to 1 so you get a better view. Now it's really going to look like a sine wave, right? And we have 3 different animation curves that we created. One goes back to 0, one bounces, and one is very smooth and goes up and down. Right? We can really see that on here on the this graph stuff. And you have the max, you see min 0, max 1. So we know that it's always, the cool range for this clear color. So we know it just by doing this, and you can, stop, right? I can play and stop everything. Just by, changing the color, we already introduced very powerful concepts here. First, this idea of basically changing values over time that we can use to drive any kind of animation. Here we're just changing the color, but it could be about changing the position of our points in space. It could be about anything. We also demonstrate the versatility of the tool, right? Or you can have different threads, different cables that works in parallel. And if you come from a programming background, this is very weird, because usually programming, you write code and it executes here. It doesn't really matter. You can have as many cables as you want, and everything is going to be triggered and executed and changed in real time. And you notice with just a simple math operation, a sine wave, absolute value, sum and divide, we created this very cool animations already. Okay. And I'm saving Control S. Don't forget Command or Control S to save your patch. Really important. Does it make sense? So, yeah, it feels weird, right? So now let's say that I want to drive this animation. So something that we could do here, first of all, if you want to see as a preview, you can click and notice that this bar here is happening, is appearing. You can change the size. You can also use this button to maximize the canvas so you have it full screen. And you can also press escape to go back to the previewer like this. Now let's say I want to change the speed. Here I'm changing it in the editor, but the user has no control over this. This is what the user is going to see. So it would be nice to create some kind of controls that people can play with inside of the patch and not here in the editor view. So to do this, we have predefined sidebar. So if you can click here and I just type sidebar, by default it creates an HTML element on top of our canvas, and you can rename it. Let's call this, I don't know, options. And then you can basically put children objects. So the one that I want here is going to be a slider, because I want to be able to change the speed of my timer. So notice that this guy is not connected, nothing happens. Now I need to connect to my sidebar. And by default, I have this slider. We're going to call it, speed. And it tells us, okay, the speed is between 2 values, anything we want. So maybe between 0 and 10. The step is very small. And our default input is going to be 1. And I'm click here to set this as default. So by default is going to be 1. And I have a slider here that I can use. Now I need to connect our slider here. It's not connected to anything, so it moves, but it doesn't drive any visual. But if I connect the result here, the output of my slider, to my timer, into the speed button, then by just moving my slider, I'm basically, driving all my visuals. And now this thing here, and if it's too big, because maybe between 20 and 10 is too big, so let's say between 0 and 2. So now we can have more control, right? It's going to be a tighter range. Now, when I open this in full screen, I still have the control, right? So now I let a basically user interact with my patch using this sidebar here. How cool is that? This is not, I mean, take some time to code this in JavaScript, right? To make the canvas, make the colors, create the HTML elements to be able to drive them. Here it's just literally 2 blocks, right? Right? That doesn't make sense for everyone here?
Yeah, that's very cool. And there is a connection with the graph. I mean, see the
right?
W. Somehow.
Exactly. It's the, I mean, I like about this tool because it's, I mean, this is when I discovered this, it really resonated with me because it's really, you think as a graph more than, because when you program, you have the graph basically, but it's in your head. You have to follow where all the blocks are executed. And just to show you what I meant, so it's really open and you can customize anything you want. So on any node, you can click here in the small dotted menu here and to view up code. So you can see actually here the code that is, this is our main loop. So by just putting some blocks, you can actually very quickly create thousands of lines of JavaScript code to create. So because they are made for you, you can fix some bugs. You can copy, create your own ops. So in my case, if I go here and I type my pseudo,
can you change the code?
Yes, you cannot change. So you need to clone it. You cannot change.
Okay,
right?
Because obviously the graphical representation wouldn't match anymore. So.
Yeah, so you need to check. This is all my ops, right? So 144. So right, and the ops that I created, but you can copy and basically clone. This is why on the button you have clone. Mm-hmm. You type the name, and then you can edit. It's your own op, right? So you can clone anything basically.
Okay.
For those who know how to program, so we have this, right? And so okay. Now we worked 1 hour just to change the colors. We're going to go quickly around, but it's about showing you how to basically reason in this weird graph representation, right? Which is very well suited to the conference. So, okay, we have this. Now it would be cool if we'd be able to display stuff, right? Now we're just changing the background, but maybe we can also, put some shape. So usually when you create the first thing you do in any program is write a hello world or put some basic shape. So here, because it's a visual program, we're going to type cube and we're going to try to connect the cube. So you know that to be able to render, you need a trigger. So now what our main loop does, it's basically clearing the screen with the color and then now draw the cube. Okay, if I want to minimize this, I can just click on the name here and it goes like this. So now we have our cube. And now you notice 2 things. First, that the cube doesn't really look like a cube, more like a rectangle. And can you guess why? Why is it a rectangle under the cube? Think of this as a scene in 3D. What happens here?
It's not a rectangle, it's a square on your screen.
Yeah, sorry, it's a square. But why is it a square and not a cube?
It's seen from the top, for instance, or from one side.
Yes, so basically if I do this is the default view and this is our cube. So we are really aligned. So the camera, think of this as a scene, right? The camera here is looking face of the cube. So there's 2 things. If this is a 3D world, there's 2 things we can do. We can either move the cube or move the camera or do both, right? There are 2 different. 3 is exactly like shooting from with your phone, right? The scene is moving, the action is happening, and you move your phone around, right? So, and if you look at the cube itself, you can play with some of the parameters, width, height, length, and you notice length is really looks like the cube is coming towards you because it's bigger in one direction. Or you can play with the height, but you cannot really move anything because moving stuff in 3D is another block, another operation. So it would be what we call transform. So you basically need to set the transformation and then draw the shape. So if you check what I do here, I put transform and I'm dragging the node and dropping on the cable. If it's one entry cable, it's smart enough to understand that it needs to be in between the two. So now when I have this transform node, I can move the cube, the position of my cube. So I'm basically saying, go to this space, go to this position in space, now draw the cube and then come back to the default position. This is exactly what happens. This is why you need to put this before the shape. So you need to say, go to this position, draw the cube and come back to the beginning. Now this is why we see it like this. But so we start to see something, but there's also something missing, right? We don't see any, angles or anything. So what is missing here?
The texture?
A texture, yes, but not exactly. It's shading, right? We don't see shadows, so we don't see what is front and what is back, right? So this could be in front of the texture, but it's really about how to what is this cube made of so that the light can be reflected differently. So this is what we call a material, because it's really the analogy with the physical world, right? Is it made of plastic, out of ceramic, out of what is the material of this shape? So by default, we're going to use what we call the Lambert material, which is just a simple material. And it doesn't really matter where you put this node as long as it's before the actual geometry, right? So you first need to set, it's a bit weird, the 3D. Usually you set the position, then you set how it's going to, what is the material, and finally you draw stuff. And by default, now I can play with the color of my material. And you notice that, by default, it's shaded. So I can start to see some of the edges of my cube. So now when I move it around, it really looks like a cube in 3D, right? And if I go in my transform, I can, move it around. Does it make sense for everyone? Saving my
I don't see the same thing as you do.
Because you change the color of the material, right? It's by default, it's just random color.
No, but actually I don't see. There's no shading on my side.
Did you put the Lambert material? Did you connect it?
Yes, I did.
Are you sure it's not just on top of the cable, really connected like this?
Yeah. Transform is connected to Lambert material, which is connected to cube.
Okay, save the patch and reload with here, maybe. But it's really weird, but...
Yeah, mine is just showing a regular square.
Yeah, I have a square also.
The square is because you...
Yes, I also have only a regular square.
You have this, right? Because the transform that you have is this, right?
Yeah.
So look what I do. I'm moving my cube a bit on the side, so you can start to see some of the the shape on the basically the depth.
Oh, okay.
It's right. It's what I said before. Otherwise, we can apply any material. If you're still in the camera, look at my camera, right? If we're just in front of this, and you see one face, so you need to move either the shape or the cameras to start to see some of the edges of your cube, right? So by moving the transform and by maybe reducing the size of our cube, you start to see things. So the transform has position, but has also rotation. So check it out. Remember that we use the animation to move the color of our background, but we can reuse this animation now to transform and to rotate our cube. So I'm connecting this to rotate Z, for instance. So it's very small because our timer is very slow. But let's say that I want to multiply this value. So the thing that comes from between 0 and 1. I'm multiplying this value by 20. And but it's still very small, so 200 maybe, I don't know. And you see that it starts to 2000, right? Because it's very small. I'm just multiplying the result here, and I'm using it to transform Z. You see, this is the last of the transform operation. So now I'm rotating the cube here, but it's still in front of the camera, so I can just maybe rotate in another axis, like here. I'm rotating around this y-axis. You see, this is the green arrow, and my shape is rotating around this axis here. Now you start to see, I think, the shapes, right?
Yeah, that's very powerful. Mm-hmm.
So, yeah, it's awesome. So this is just the beginning. This is the beginning. You will see what we can do after. But now, I just want to, so that it's very clear for everyone, we are transforming the shape. So we're saying, hey, draw each frame, draw at this position, color our rectangle, draw it. Now, next frame, we change a bit the position. The color is the same, but we could actually also use this to change the color, right? We could do this and have the shape of the cube itself would change the value exactly as we had before, right? So it's going to be more or less, green if I do this, right? So it's going to change color over time exactly as the background. Does it make sense? And but it's not very good to do this, by the way. It's not very cool to change the material. It's going to be a bit slow. If you do this, it's going to slow the computer because it's not usually the way we do this, but just to show you that we can basically map all the values.
What are the min and max values of the transformation for the rotation?
So it's a very good point. So when you are in a scene, usually we are in meters, but it's an infinite space. So this is like 1 meter here, 1 meter here, but it could be anything. Now, if it's too far, then the WebGL is gonna say it's too far, so I don't draw it. I'm gonna clip.
Yeah, but what about the rotation? Rotation is an angle.
Yes, but it's always gonna be multiples of 360 degrees, so it's gonna go back.
Okay, so that's it. That's degrees.
Yes, here it's degrees, right?
Okay.
So like we are 1,000 or whatever degrees, right?
Okay.
Right. Now, something that I mentioned, so we talk about moving the shape here, but we can also move the camera, as I mentioned. So the usual camera that we want to use is what we call orbit controls. And we need to, so basically it centers the camera around the center of the scene and lets us move around it. You need to put the camera before the transform, but it doesn't matter if it's after the clear color or before. Just before once again, the last thing you need to draw is the shape, basically. So I can put this here, but you can put it anywhere as long as it's before before the cube. Usually we put it on the top or just after the clear color. So if I want to move it somewhere else, I can take the shape, shake it, then it starts to disconnect, and then I can, connect it below. But I think it was a bit clearer with all the cables that we had, so that's why I put it here.